Okay, question 9 is a circle theorem proof question. Most of these start by drawing in radii that aren't there. So I'm going to draw two radii, one from D. Just pretend I know where the centre of the circle is. Oh, where's it gone? Let's try that again. Okay, and one from B. It's important that these are from opposite vertices in this question. Okay. Now we're going to use other circle theorems to prove this circle theorem, and that's allowed when doing this. So if we label this x, this angle at A, we're going to say let angle BAD equal x. Okay, and this centre of the circle, by the way, that we've just made, we're going to label O. Okay, so by labelling that angle x, we can now use the angle at the centre circle theorem to say that this must be 2x. So angle, now I'll come back to this in a second, but if we call this angle BOD, the angle that would normally refer to would be the the obtuse angle there. Okay, so we always go with something that's less than 180. So if we want to talk about the angle on the other side, on the angle 2x, we want to say reflex angle. So reflex angle BOD is 2x, because the angle at the centre is twice the angle of circumference. Okay, now we could label this one y and say that this is 2y. You could also label this one, rather than 2y, 360 minus 2x, and this would be 180 minus x. Okay, so there's a couple of different ways of doing this. I'm going to go with y for this one, I would normally advise not to introduce a new letter to these sorts of things, but I just think that it makes this one a bit easier to then conclude. So we're going to say let angle BCD equal y. Now we don't have to say reflex this time, angle BOD, without putting the word reflex first, then people should just know we're referring to the one that's less than 180, equals 2y, because again, angle at the centre. Now, we know that 2x plus 2y form a complete angle around a point, and we know that altogether that's going to be 360 degrees, because angles around the point add to 360. Okay, and if we halve all of that, divide that whole equation by 2, we end up with x plus y equals 180, and therefore we've proved that opposite angles in a cyclic quadrilateral add to 180.